Welcome back to the Explainer. We've got a massive, rapid-fire news digest for you today covering the week ending August 4th, 2026. It's EP 303 Breakout. And honestly, we are watching a profound shift in the security landscape right now. We're literally seeing the evolution from traditional human hackers exploiting databases to state-sponsored actors targeting our physical world, all the way to a completely new frontier: autonomous AI agents running their very own cyber attacks. It is a wild time, so we've distilled the most critical updates right here for you. Okay, let's dive straight into the agenda. Today we're covering exposed wealth and tax data, water infrastructure under attack, the emergence of autonomous AI cyber attacks, Graham, the AI safety switch, and finally, Astra solving open math problems. Starting things off with Section 1, exposed wealth and tax data. We're structuring today's explainer along what I like to call the cyber-physical cognitive continuum. So we're starting in the digital privacy realm with some classic but incredibly high-stakes data breaches that just hit the wire. 31,000. That is the staggering number of records compromised overnight on July 29th from Liechtenstein's government-maintained register. Now, the government did establish a crisis unit over the weekend to investigate this, and while no records were actually deleted, the exfiltration of this specific data is sending absolute shockwaves through the financial world. Now, you might be wondering, why is this specific data so uniquely sensitive? Well, it comes down to beneficial ownership. This is all about unmasking the natural persons, the actual human beings who ultimately own or control a legal entity. We're talking about piercing through incredibly complex layers of trusts, foundations, and shell companies. You know, Liechtenstein is a well-known wealth haven built on discretion, and this registry was created specifically to comply with European anti-money laundering rules. This breach strips away the corporate armor designed to protect the privacy of hidden wealth. It's not just your standard identity theft risk, it's literally a map of who sits behind these massive structures. That is a treasure trove for intelligence services or extortionists. And speaking of extortion, check out this terrifying timeline from a massive supply chain attack hitting Ernst & Young. The notorious extortion gang Shiny Hunters claimed this one. Look at the gap here. The initial breach of a third-party IT platform began way back on March 28th and ended April 12th. But Shiny Hunters didn't pop up on the radar claiming they had accessed EY's Jira, GitHub, and Azure environments, along with client tax documents, until July 27th. And then they issued a rapid extortion deadline for July 31st. This brilliantly illustrates the hidden danger of supply chain attacks. The initial compromise happens months before the real damage, and the extortion demands are even known to the public. Moving right along to Section 2, water infrastructure under attack. Moving down our continuum, we're shifting from digital data into the physical realm. And this is where cyber attacks start spilling over into tangible, real-world anxieties. Just look at the sheer scale of this incident. Over just 2 days, July 26th and 27th, a coordinated attack struck more than 30 communities in Minnesota, with related activity popping up in at least 6 other states, including Michigan and Wisconsin. This wasn't just a simple network intrusion either. The attackers disabled computerized operating controls, forcing local operators to literally disconnect cellular equipment and manually override systems just to keep clean drinking water flowing. Thankfully, water quality remains safe, but this massive physical disruption is being attributed to the Iranian state-affiliated group known as Cyber Avengers. So how exactly did they pull this off? As the recent CISA advisory points out, they're exploiting Internet-Exposed Programmable Logic Controllers, or PLCs. What you really should take away from this is that state-sponsored groups like Cyber Avengers aren't always using mind-bending, complex zero-day exploits. Nope, they're going for easy wins. They are actively hunting down critical physical infrastructure that's been carelessly connected to the internet with default or weak passwords. It is a super low-cost, low-risk way for them to project power and create widespread panic. Which brings us to Section 3, autonomous AI cyber attacks emerge. This brings us to the bleeding edge of our continuum, the cognitive realm. Because while human hackers were busy manually exploiting those water facilities, AI agents were quietly running their very own automated exploits. A Chinese-speaking threat actor tried to launch an autonomous cyber attack campaign. First, they tried using closed-weight models like Claude and OpenAI. But the built-in safety filters successfully blocked their offensive commands. So they pivoted. They moved to an open-weight model called DeepSeek. Since DeepSeek's API lacks those hard-coded commercial safety refusals, it just accepted the malicious tasks and reasoning commands natively. It perfectly shows how unrestricted models can effortlessly bypass the safety guardrails the industry has been working so hard to build. Once they had this willing AI reasoning engine, they hooked it up to an orchestration framework called the Hermes agent. And the process here is just shocking. With a single initial prompt over Telegram, the agent autonomously searched the FOFA engine for vulnerable internet-facing systems, downloaded the exact right exploit code from GitHub, and then launched the attacks. Literally zero human operator input was required after that very first command. What would normally take a human red teaming crew weeks of labor to orchestrate was compressed into mere hours by an autonomous AI agent. Let that sink in for a second.
Let's move to Section 4. Graham, the AI safety switch. So how on earth do we defend against this cognitive threat? Well, Gradient Routed Auxiliary Modules, or GRAM, is a defensive breakthrough that fundamentally changes AI architecture. It builds a completely new paradigm for AI safety. Instead of teaching an AI everything and then trying to train it to politely refuse bad requests, GRAM structures the knowledge physically during training. You have a massive core MLP that handles general language and universal reasoning. Then you've got these tiny auxiliary MLPs. We're talking only 6 to 10% of the core size that are algorithmically forced to hold all the highly sensitive, dangerous knowledge. Because they're completely isolated, these sensitive modules can literally just be switched off when deployed. And the best part? You don't have to retrain the entire multi-billion-dollar model. The absolute crucial point to take away here is this. Physical isolation is greater than behavioral rules. Usually, if you try to jailbreak a standard model, you might trick its behavioral guardrails into giving you dangerous code. But with GRAM, you can't jailbreak the dangerous knowledge out of the model because those specific neural weights have been physically removed. The knowledge literally does not exist in the version you're interacting with. It's a massive game-changing leap forward in making models genuinely secure against the kind of autonomous exploits we were just talking about. Finally, Section 5, Astra solves open math problems.
While security teams are scrambling to contain AI, the frontier of AI reasoning capabilities just took a monumental leap forward over at OpenAI. $2,000. That's it. That is a surprisingly low compute cost it took for an internal version of OpenAI's upcoming Astra model to produce 10 brand new results in advanced unsolved mathematics. To put that into perspective for a second, human research teams spend years and vast amounts of grant money chasing even one of these results. Astra did 10 for roughly the price of a mid-range laptop. Let's be incredibly clear about what this actually means. We aren't talking about simple benchmark tricks or standardized tests here. These were 10 problems that had remained completely unsolved by professional mathematicians for at least a decade. The model constructed a non-Sophic group, disproved Cohn's rigidity conjecture, and advanced high-dimensional sphere packing limits. And it didn't just guess. It published machine-verifiable Lean 4 proofs directly to GitHub so the mathematical community could verify every single step. This is genuine, superhuman reasoning capability in action. And that brings us to the ultimate question for this week. As AI models become undeniably capable of autonomous high-level reasoning, whether it's solving decades-old math problems or autonomously chaining together cyber exploits across the internet, are we truly ready for what they'll solve or exploit next? From Liechtenstein's exposed wealth to manually overriding water pumps in Minnesota, our physical and digital worlds are already under immense strain. Add autonomous AI to the mix, and the game has completely changed. Thanks so much for joining me on this explainer. Keep your systems updated, and I'll see you next week.